Hey everyone, my name is Vijay and welcome back to the Mastering SQL Server, a comprehensive training. This is part 2 where we are diving deeper into advanced SQL Server features to help you work smarter and boost performance. If you haven't seen part 1 yet, please make sure to watch that first. It covers the basics you will need for these sessions. Let's jump right in. So in part one, we have seen multiple queries like subqueries and nested subqueries. So in this, we are going to start with the correlated subqueries. So in the correlated subqueries, main query will execute first, then the value of that main query will be used for the correlated subqueries. When main query is executed, then the copy of that the table will be stored in the memory. Here is the example. Write a query to get the details of employee with the first year salary. Okay, let's check in the real time. So this means we have created the employee table yet. So let's first create the employee table. Okay, now so this is the sub so you can see here in the emp1 table we have 3 records, and when we use subcorrelated query, then it gives us the first high salary of 60,000. So if there is any number like 0, 1, 2 are present in where clause, then it is correlated subquery. Set operators in SQL Server. So set operator will work on multiple tables. Set operators are used to join the result of two or more select statements. It will show two result as one result. Set operators are used to join rows or records of different tables, whereas joins are used to join columns of different tables. So there are different types of set operators in Server, and those are union, union all, intersect, and except. So union is used to display unique values from both the tables, and it will remove the duplicate entries if both queries return new arc. For example, if both queries return the new arc, then only one new arc will be appear in the result. So in union all, it will shows the values from both the queries including duplicate values. It is faster than union because SQL Server doesn't perform the distinct sort. If both queries return new arc, it appears twice, means the duplicate records. Intersects. Uh, it will display similar values existing in both the tables. Only cities that appears in the both tables are returns. It automatically removes the duplicate records. So except displays the value from the first table which are not existing in the second table. So it shows cities that are in customer but not in supplier tables. It also removes the duplicate records. So let's see the practical example of union all, intersect and excepts. So for this, first we need to create the table customer and the suppliers. Okay, let's have a practical look. So now I have created the customer and supplier table. Let's insert data into those. Okay, we have created the customer and the suppliers tables. Let's execute the select query on both. Let's see the records. Now let's have the real-time example of the union. First, check the records of customer and supplier tables. So this shows the customer's records and this shows the supplier's records. Now, if when we apply union on the customer and supplier tables, then it gives us result as Boston, Chicago, Dallas, New York, and the settle, because it removes the duplicate records. Now let's have the example of union all. Let's execute. So you can check here New York, Chicago, Dallas, New York. In the customer we have duplicate records. In the suppliers we don't have the duplicate records. But when you see the union all, you will see the New York, Chicago, Dallas, New York means New York and Chicago are the duplicate entries in the result of union all. Now let's have the real-time example of customers, real-time example of intersect. So intersect will display the same record from both the tables. Here Chicago, Chicago. Now let's have the real-time example of except. Okay, so in the first table we have Dallas, we have Chicago, we have New York. But in the second table we have Chicago, Boston, and Seattle. So it will gives us the records from the first table that is not exist in the second table, that is Dallas and the New York. So what are the conditions uh, or the rules for using the set operators? So each select statement must have the same number of columns. Columns must be in the same order. Data type in corresponding column must be compatible, that is int with numeric, char with varchar. Order by can appear only once at the end of the combined query. Here is the set operator continuation. Here is the table. So it gives the difference between union, union all, intersect, and except. So this is the Venn diagram of showing how each SQL Server set operator works. Here is the union means combines the result from both the queries, union all, then intersect and the except. Now merge statement. So merge statement is used to add records of one table in another table. Based on the common column names, records can be merged in another table. It work with the update and insert command. If matched value are existing, then update command will work, and if matched value are not there, then inserting command will work. Here is the syntax of the merge statement. Merge into source table using destination table on condition. When matched, then update command. When not matched, then insert command. Here is the example of merge statement. Let's have real-time example of merge statement. Now, first let's check EMP1. Here, the Dana, UN, and Fair are added in the EMP1 table, and Dana, UN, Fair updated in the EMP2 table. Now, joins. Joins are used to show multiple tables as one table. Joins are used to join columns of different tables. There are different types of joins, that is inner join, outer join, cross join, or Cartesian join. So let's started with the inner join. So while joining the tables, if the tables are having matched records or related records, then inner joins are used. There are two types of the inner joins, the equijoin and the self joins. So in equijoins, table can be joined by using the equals to symbols. So we can have the real-time example of the equijoins. So before starting the equijoins, let's create a department table and add the records into department table. Let's check. Okay, we have 4 records. Now let's uh, have the real-time example of equijoins. Okay, here the this is the result of employee 1 table, this is the result of department table, and this is the result of equijoin. So equijoin can also be called as the natural join. For joining the tables, column names can be a same or column name can be a different, but the values in the column should be the same. Now self join. So a table can be joined to itself if different columns in the table contain the similar values, then self join is used. Let's see the real-time example of the self join. So before having the real-time example of self-join, let's create employee table. Okay, and now let's add values into the employee table. Let's check values of the employee table. Okay, now let's have the real-time example of self-join. So in self-join, we are performing self-join based on the manager ID and the employee ID. So here is the result of the self-join. Now the second join type is the outer join. So while joining the tables, if the tables are not having matched records or related records, then outer joins are used. There are different types of outer joins, which are the left outer join, right outer join, and the full outer join. So left outer join, it will take all the records from the first table and will join with the matching record of the second table. So let's have the real-time example of left outer join. First, let's create a table, EMP department. Let's check the values of the EMP department. Here is the values. Now also check the values of department table. Okay, HR. Here in the department we have the HR department, finance, IT department, and marketing. But in the EMP department we have HR, finance, and the IT departments. Okay, let's have the real-time example of the left outer join. Now here it will returns all the means all the records from the department table and the matching record from the EMP department table. Now let's have a look at the outer join. So outer join, it will take all the records from the second table and will join with the first table. Let's see the practical example of the right outer join. Here it is the result of the right outer join. Now let's have a look on the full outer join. So it is the combination of left outer join and the right outer join. It is used to display all the records from both the tables. Let's have the real-time example of full outer join. So here is the result of full outer join. And the next type is cross join or Cartesian join. So in this, each record for the first table will join with all the records in the second table. Here is the real-time example of this. So it gives us 12 record because in the first table we have 4 records, and in the second table, that is EMPDP, we have 3 records. So it multiplies and gives us the 12 records. And here is the visual Venn diagram of different types of SQL Server joins. Now views. View is a logical table used to display required information from the table. View will be created by using select statements. View will not store any values and will not use memory. In view, physical data will not be stored. There are 4 types of views. Those are simple view, complex view, indexed or materialized view, and the partitioned view. So let's have a look on one each view type. So the first is simple view. So simple view is created by using the select statement with where condition. When we create a view on a single table, then it is called as simple view. So here is the real-time example of same simple view. So before starting with the real-time example, let's create a table employee. Let me drop this and then the create, and let me insert the values. Okay, now let me check values, the employee table. Okay, 1 2 3 4. Let me create a simple view. Okay, I have created the simple view, and let me get the data from this simple view. So this view employee gives us the all the employees which having the department as IT. So here you can check, we have Bob and Ram whose department is IT. In simple view, we can insert, update and delete data. We can only insert data in simple view if we have primary key and all not null fields in the view. So let's have the real-time example of insert, update and delete records from the view. So let me first insert the record. Okay, now let me check whether the record is inserted or not using the view. So now it gives me 3 records because the third one record is added. Now let me update the record, means let me update the records using the simple view. Here is the view name. I'm updating the name of employee to Raj, whose employee ID is 104, means Ram. So now the Ram is updated with the Raj. Now let's uh, perform the delete using the view. Now let's check whether the employee ID 105 is deleted or not. So it's not giving 105 means that record is deleted. So in this way we can perform the insert, update, delete using the simple view. The second is the complex view. So complex view is created with one select statement having order by or group by or else by using joins. When we create a view on more than one table, it is called as complex view. Here is the real-time example of the complex view. Here is the example 1. Now I have created the view which gives me a top 3 employees. Okay, let's check the employees. Now we have 4 employees. Okay, now okay, so it gives us the top 3 employees by order by salary descending. So first is 60,000, 55,000 and 52,000. Now we can only update data in a complex view. We can't insert data into the complex view. Yeah, okay. So before that, we have second example of the complex view. Let's have a look into that. Now I have created the second view, that is view MPD DPT. Now let's check what it returns. So it will give us the records. So to see views in the current database, we can use the syntax. So it gives us 3 views, that is the view employee, view top 3 employee and the view EMP department info. To delete view, we can use this syntax. So I want to delete the first one, simple view. Okay, so drop view and the view name. Now view is deleted. Let's check whether the view is deleted or not. So that view was deleted and it gives us only 2 records. So here is some note, some points that let's keep in mind. We make views for a security purpose since it restricts the user to view some columns, fields of the tables. One more advantage of view is data abstraction since the end user is not aware of all the data present in the database table. Want to use queries without rerouting them and need a consistent data structure for reporting or applications. Here is the syntax that we have already done. Now the next type is indexed view or materialized view. If index is created on the view, then it is called as materialized view, and it will not show the records in ascending or descending order, but faster access of data will be there. Physically stores the query result in the database and performance useful for aggregation heavy queries requires with same binding. Let's have real-time example. Okay, here is the real-time this example of indexed view. Let me create a view. So view is created. Let's check the result of this view. It gives us the result. Okay, now let's check whether view is created or not. Here is it gives us three records, means view is created. Here is one point that we need to keep in mind, that is after schema binding no modification can be done on existing columns, meaning after schema binding you cannot change this column in the employee table until the view is dropped. So to check the schema binding we can use this syntax. Let's check in real time. Okay, here, sorry, my bad. Here it gives the result. To here is the syntax. To create an index on the view, that is create unique clustered index, that is the index name on the view name, and here is the column name. The last one is partitioned view. So partition views combines the data from multiple tables, usually in different database or servers, using union all, often used for large data sets. Here is the real-time syntax of partitions view. Let's create this table. Now let's create another table. Okay, we have created two tables and we haven't inserted any values into the table. Let's insert the values. Now we have added the values into the employee 2024 and the employee 2023 tables. Now let's create a view partition. Now let's create a partition view. Now check the view is returning value or not. So it's returning the value, correct values. Okay, so next is the indexes. So indexes will be created on a table so that the records in the table can be accessed quickly, and the records will be displayed in ascending or descending order. With the index, table execution performance will be increased. Index in SQL Server works automatically. Index can be created automatically or manually. Automatically means with the primary key constraints, cluster index will be created. With the unique constraints, non-cluster index will be created manually. Manually means user can add index for the required column in the tables. So here is the syntax to create the index. Let's create the index in the real time. Now I am creating a non-cluster index on the column department. Okay, so index is created. There are two types of index. One is the cluster index and non-cluster index. So let's have a look on the cluster indexed. So based on the index column, the records in the table will be physically rearranged. A table can contains only one cluster index. In a cluster index, the data itself is sorted and stored in the order of the index column. Example, table employee cluster indexed on the employee ID, physical storage on disk cluster index on the employee ID. Okay, here is the example. Now, so what happens here? The rows are physically arranged on the disk by employee ID. The cluster indexed and the data are stored together. There is no separate structure. This makes searching by employee ID very fast. The non-cluster indexed. A table can contain 249 non-clustered indexes. It will not change the physical order of orders in the table, but with the help of index, data can be accessed quickly and records will show in ascending or descending orders. In a non-clustered index, the data stays in its original order and a separate index structure is created that points to the data rows. Example, employee table non-clustered index on the employee name. Okay, here you can have a look how non-clustered index stored separately, employee name, pointer and rows address. So here is the John pointing to the second row. Okay, the Bob is at the row 4, the David as row 3, Ram is at row 1. So what happens here? The data, the table data's physically order does not change. The non-cluster index store a sorted list of employee name values with a pointer to the actual data rows. This helps SQL Server find matching rows quickly without searching the whole table. Here is the syntax to create an index. Create unique cluster non-cluster indexed index name on table name, column name, and the ascending or descending. So this syntax is used to drop this index. So let's drop index in real time. Okay, so we have created index on the table employee. Now let's drop that, and now we have dropped that index. To check the indexes with the constraints, uh, let's have example. it's already exists, so let me first drop, or let's create a new table, that is employee 10. Okay, now we have created indexes with, means we have created a table. Now we can check the constants using the syntax. Here is the primary key constants. Non-clustered index, the result of that sp underscore help constraints. Example, using cluster index, create cluster index my index on emp1. Here is the example. Okay, now we are going to create it on the employee emp table 10. Let's create first. Okay, because we have already created a primary key constant. We haven't inserted the records, and here is the syntax of deleting the index, drop index table name dot index name. And here is the example of a non-clustered index. So create non-clustered index name on table name, then the column name, and here is the select statement and the drop statement. So we can work with multiple non-clustered index. Here is the syntax. So create non-clustered index my index 4 on emp4, include ename and salary. Ename and salary are the columns. Okay, also we can create another non-clustered index my index 5 on emp4 on the column salary, includes ename and ename and enumber. So here is the select statement. Select start from emp4 where e number greater than 101, and the select start from emp where salary greater than 1000. So it will return us the e number in ascending order and the salary will be in the ascending order. So some points that we need to keep in mind: if a table contains the multiple non-clustered index, then two conditions should be satisfied. Those are: select statement should have a where clause and index column should be given in where clause. Clustered and non-clustered indexes can be non-unique or unique indexes, and the default is non-unique. If the index is a non-unique, then it will work on the column containing duplicate values. If the index is unique index, then it will work with column containing unique or different values. So to view indexes created on table, click on View Object Explorer. So let's check in real time. View Object Explorer, database. Here is the view, and you can see the view, all the views created. Okay, to view indexes created on the table, okay, double click on database, database name tables. Okay, Here is the table. Suppose let's go into the table and check the employee. Expand that. Here you can see the indexes. The next one is the pivot. So pivot is used to display the values in crosstab or matrix format. If table contains duplicate values, then the without duplicate value to display the result set pivot option is used. The value in the table will be used as a row heading and column heading. Pivot is used when we want to transfer data from one row level to column level, and unpivot is used when we want to convert data from column level to row level. Here is the syntax of pivot. Select a non-pivot column, list of pivot column from select query to produce the data as alias name pivot, aggregate function column name for column name that become column headers in list of pivoted columns as alias name for the pivot column. So let's create a cells input table, and here is the example of that. Select start from cells info pivot sum of cells in the year to 2022 and 23A. Note: cells and year means column name and A means temporary column, likely intended to mean alias or the temporary tables. Let's have this. Let's have look this in real time. So let's create a cells input table. Okay. Now let's add some values. Now let's create a pivot. Now have let's have the means let's have the result of pivot. Okay, so first is the result of cells input table, and this is the result of the pivot. So here Ford is in year 2023. Okay, and the Toyota and the Honda is in year 2022. So it gives the Honda and the Toyotas that is in year 2022, and we don't have any uh, sales info for the year 2013. Now let's have a look on the common table expression, which is nothing but CTE, and CTE is used to give temporary name or alias name for the query or the select statement. So here is the syntax for that with CTE name column names as query select statement and select start from the CTE name. So let's have the CTE in real time. Okay, employee ID, employee ID, employee name, department, and the salary. Okay, as select star from employee where salary greater than 10,000, select star from city. So it gives us the records having salary greater than 10,000. Let's change the condition. Okay, and now let's check. So it gives us only 2 rows. So this is the part 2 of SQL comprehensive training session. If you feel this session is fruitful for you, then you can like, subscribe the Junkie Tech channel for more tech videos. Thank you.